In this demonstration, we're going to start with this pentagon, drawn in Rhino, that we're going to use as an underlying structure to help us construct a 5-pointed star. The shape is drawn as one continuous polyline so that it registers as one object in Rhino's data structure. But we can see many different parts embedded in the figure with our eyes, and Shape Machine can help us restructure the drawing for any inquiry we want to make. In these examples, we're going to focus on the closed polygons we can see embedded in the star that can be mapped under similarity. So on the left, we're constructing a smaller, similar version of the 5-pointed star as a reference structure that we can draw on top of for the polygons that we want to search. So we're going to start with a 3-sided shape, and this computation will be familiar to you from the work of George Steiny. So we draw an isosceles triangle on the reference star, and we can ask Shape Machine to tell us how many of these isosceles triangles are embedded in the star under similarity. And the red highlight shows the matches that Shape Machine finds. We can cycle through them, and when we see one that we want, we can pull it apart from the original geometry to see that the shape can be described as a concave quadrilateral and an isosceles triangle. And what about a 4-sided shape? And not the concave quadrilateral we just saw, but what about a convex quadrilateral, like this one we've just drawn on the reference star? We can ask Shape Machine to tell us how many convex quads are in the 5-pointed star by selecting the search shape on the left and the target design on the right. When we cycle through the results, we can see that Shape Machine has found 5 matches. And when we select one and cut it from the original drawing, we see that the 5-pointed star can also be described as a heptagon and a convex quad. And we can partition the shape any way we like. So say we want to search for a 5-sided shape, a pentagon. We can draw one on top of the reference star and use the similarity mapping in the Shape Machine to search for the pentagon as embedded in the larger 5-pointed star. And Shape Machine will find the one result in the center of the star, and when we pull it apart, we can see that the star can also be described as a decagon and a pentagon. And we can reverse the argument and change our mind anytime we want. So say we want to search for the concave quad that we found when we pulled apart the isosceles triangle. We can draw it on the reference star so that we can search for it and see how many of those concave quads are in the larger star. Cycling through the results, we can pick one that we like, separate it from the original drawing, and see that we have an isosceles triangle in the concave quad. And say we want to search for the heptagon to see how many 7-sided shapes are in the larger star. We can trace the heptagon on the reference star and we can search under similarity for this kind of fox-looking figure by selecting the search shape on the left and the design on the right. And when we cycle through the results, we can select one we're interested in and pull it apart from the drawing and see that the 5-pointed star can be described as a convex quad and a heptagon.